Hello and welcome back. So on the workbench, we still have that BC3300 that's under repair. And as you can tell by the disassembly of it, replacing the power supply board did not fix it. It still has problems. Specifically, it just doesn't do anything. But I think I've tracked down, so I've been testing all the boards and everything, and everything looks fine. There's nothing majorly blown up. But I'm down to the gate driver now. And I have actually worked on this battery charger before. It does have my replacement cap board in there, which is in pristine condition. Like there's no bulging caps or anything. It's nice. So not the problem, which is good. I've never had one come back with a replacement board in it ever. Like this is the first one. And specifically, I've never had one come back that had my replacement board as the problem. So I don't know. I thought that's pretty good. But anyways, so this is the gate driver board. So there's two things I noticed on it right off the bat. Number one, there's a 0.9 ohm resistor down here. I don't know if I can get the light right. Wait a minute, hold on. Is that better? Yeah. There's a 0.9 ohm resistor down in there that's gotten very hot and melted into the connector. Probably going to cut that out and replace it. But I don't think that is the actual problem because it still measures 0.9 ohms. And I think that's an artifact of that 12 volt supply running high at 15 volts. And I think the reason why it's running high, because I put another replacement board in, and another power supply board in there, and it also ran at 15 volts. Normally they're just at 12. But then normally when they're plugged in, things are running. So I'm thinking that puts enough load on the switch mode supply to get it down to 12 volts. It might just be like a fixed pulse width duty cycle supply. And maybe there's a zener or something that clamps it. They're very fond of zener diodes in these designs for clamping things. Speaking of which, that is what I found so far to be the problem on this side of the board. So this is essentially the logic side. These are the gate drivers. Well, they're not gate drivers. They're they're pulse transformer drivers, because see, these connectors are actually what plug into these pulse transformers here. They're the ones that actually run the gates on all the MOSFETs down here. But I mean, you could consider them gate drivers. They're just transformer coupled to the gates of the MOSFETs. If you hear noise going on in the background, that's Milo deciding to play with some bubble wrap. Okay, anyways, so ignore the cat. But anyways, yeah, so what's going on here is we noticed that this board has gotten a little warm under the diodes here that form a bridge rectifier. And this is taking AC in, it's bridge rectifying it, and generating a 5 volt supply. This is a 4.7 volt zener diode. This capacitor is in parallel with it, and this creates a 5 volt supply to run this comparator and provide power for this transistor here, which runs this is a linear photocoupler, and then this is the comparator runs this optoisolator. So what is this doing? Well, it's taking in essentially, it's kind of spread out weird, but what this does is, well, let me show you, hold on, let me show you this first. This zener diode here, this guy right here, is shorted. So that is most likely, that's 90% of the problem here. And I'm hoping, let's see if I can get do the old chopsticks on the probe here. I can probably get on here. So we're definitely shorted. So I don't know if it's the capacitor, because this looks like a pretty old capacitor, or the zener. Most likely it's the zener. So I'm going to have to lift the pin on it and see what we can, if that's bad. If it is, I've got replacements. I have specifically for this 4.7 volt zener diodes. So looks like I've got a few brand new, never been opened. specifically for this. But so essentially what this does, we got bridge rectified AC coming in here. We don't know if it's 120. We don't know if we're plugged into 120 AC or 240 AC. That gets bridge rectified. These are 1N 4004s, so they're good to like 400 volts. And we go ahead and bridge rectify that, and that goes to between these resistors over here and this zener diode, and that generates a 5-volt local supply which powers everybody over here. Curiously, this zener way out here forms with this resistor. Now this resistor is the current limiter. You can see it running up to this photocoupler here. But this guy creates essentially a reference for this comparator. So if we're above that reference, we're plugged in, and that essentially tells this guy to turn on, which goes out through this connector here and tells the micro to boot up. Well, it starts the power supply that the micro is connected up to, so that when you plug it in, it boots up. And that's what's not happening. We're not booting up because this circuit is not being powered because this supply shorted out. The other side of this, we've got a few resistors. This transistor generate a linear photocoupler, or power this linear photocoupler. This is essentially acting as an amplifier. And this measures the input voltage. So if we're running at 240 or 120 AC, that sends that voltage over to the micro, and it goes out through there too as analog voltage, so it can measure what the input voltage is, so it can know if it should operate in boost mode or buck mode. So yeah, it's pretty simple. So I think it's this part that's bad, so I'm going to replace it. Maybe I'll replace, if I can find I don't know if I've got a 0.9 ohm resistor. Milo, you are the most annoying cat ever. What are you doing? I'm trying to record a video and you're like pushing my arm. What are you doing? Yeah, okay. He just wanted to be in the video. But anyways, so yeah, that's what I'm going to do. We're going to replace this guy. I think that's what it is. I'll probably replace this capacitor because it could be that this cap is going bad and we've got a lot of ripple current. That could be causing issues too. So I'll probably replace this capacitor, this zener diode, and yeah, hopefully that fixes everything. I'll look and see. I might have one. I'll have to check and see if I have a 0.9 ohm resistor, if I can even get it out of there, because it is kind of like melted into the connector. It's kind of squished in there. But anyways, we'll see what happens. Thanks for watching. Bye.